Hello, everyone, and welcome to Engineered to Ask, brought to you by the College of Engineering here at the University of Nevada, Reno. This is your host, Anthony Kuhl, and with me today is Dr. Feil-Seifer, a professor in our computer science department. Thank you so much for joining us on the podcast today. How are you doing?
Doing well, thank you.
That's great to hear. So today we're going to dive into the field of robotics, and Dave here is going to help us get a better understanding of what this area of engineering and technology is all about. But before we get into the main topic today, why don't you tell us a little bit about yourself and what brought you to the field of engineering in the first place?
All right, sounds good. I'm a professor of computer science and engineering here at UNR. I've been here since 2013. And my research area is in human-robot interaction, and I teach robotics, HRI, artificial intelligence, AI. I also teach I've taught the Intro to Programming course, and right now I'm teaching in the Capstone series, so software engineering and senior projects.
Oh, wow. So you're involved with, or at least have experience working with, every aspect of the robotics field.
Absolutely.
Haven't you?
Yeah, my main area of research is how humans and robots can collaborate, can not collaborate, how people want to use robots in workplace or educational settings, and sort of that interface between humans and robots. So the work that goes on in my lab is a mixture of technical development, making robots do cool stuff, and then social interaction studies, so studying how people react to those things and how to facilitate optimal collaboration behavior.
Nice. So then that actually brings us into our main topic full force with robotics. Now, I definitely feel like it's one of those areas of research that I feel a lot of people have expectations forced on them, be that either from movies or from television. So what's your opinion on the current state of things when it comes to robotics? Where are we at with, obviously not science fiction technology that we see there, but are there any recent breakthroughs that you know of that you really think are exciting?
Yeah, it's kind of funny to think about media and popular culture with robotics. When I first started grad school, it was 2003, and I had just moved to LA, and they were recalling the governor, and the candidate that was replacing the governor was Arnold Schwarzenegger. So there's, watching the Terminator become governor all of a sudden, it's like, oh, yeah, we did it. Recent advancements have been far and wide. So on the purely robotics side, both sort of commercially available robots and research platforms are much more interacting with the world. So able to do bipedal walking, being able to navigate on terrain, both even and uneven. It used to be you had to have these very sanitized lab environments, and robots are more and more getting out into the world. So I think that's one place where we're seeing a lot of advancements. You're seeing humanoid robots from a variety of companies able to do more and more complex things. And you're starting to see these actually be used in a viable sort of working capacity. On the uses robotics skills, but wouldn't be a robot that you would think traditionally. Autonomous vehicles and aircraft, drones, UAVs, all of these platforms really are, again, more and more getting out of the lab environment into the field. And so you may have had an interaction with a Tesla on autopilot, or you may have seen a drone being used to do a real estate survey of a site, or even just doing a crowd flyover at a wedding and recording a video for people to see. And so that's more, I think that's more of sort of things that don't look like the robots that we started off thinking would look like. And then finally, generative AI. So things like ChatGPT or other large language models are helping to make available to, I think, more the average user, more people who are not engaged with the development of artificial intelligence to be actually using AI. And we're seeing more and more people that are being assisted by these systems, that are being able to really engage with AI in a way that they haven't been able to before. And if robotics is embodied AI, that means that more and more of these capabilities are being brought to the real world.
It's really fascinating how broad it seems robotics has kind of gotten. And just like how you were talking about, the different platforms that they're all kind of going in, different directions. Like earlier today on campus, I saw one of those little food delivery robots. And it's
Not mine.
Yeah, but it's interesting to see that the shape of a device like that went with something totally not, despite, being something that is designed to interface with humans, isn't really reflecting our own biology in any way.
Yeah, so I think as robots start moving away from a literature constructs, something that Isaac Asimov is thinking about or other authors are thinking about, and more moving into having a job, the shape, the morphology of a robot, the use of that robot is starting to be driven by the nature of that job. So a food delivery robot is essentially, a warming or cooling package on wheels that needs to get from one place to another. And so, yeah, it looks more like one of the robots that we would use in the lab to just sort of move around and not really have arms or legs in the way that we would think of, because that's all it needs to do the job. You can do it cheaply, and you can have a robot that is capable without necessarily looking like a biological, a human or an animal, and be able to do its job effectively.
That's so interesting. Something that I think is really important is for our students here, because we have mechanical engineering, we have electrical engineering, we have computer science engineering here at the College of Engineering. But which of these fields, or what studies do you think for students should be focused on if they're really thinking about getting involved in the field of robotics?
So glad you asked, because we just created this, and so now we're announcing it. At the undergrad level, you can be a major in just about anything in engineering and work with a roboticist, because our work extends to a lot of different engineering domains. But we've created a robotics minor that is now available, so you can get engaged with robotics really from any of the majors in engineering, and especially mechanical engineering, computer science and engineering, and electrical and biomedical engineering. It's a nice pathway to study robotics as part of your overall instruction.
Interesting. Now, actually, I want to cycle back to something you mentioned earlier with the involvement of artificial intelligence and AI. So how do you feel that's going to interact in the future? I mean, obviously, you need, programs and systems to actually control the mechanics of a robot. But where do you think that's going to lead with the current trajectory that we have with generative AI models and artificial intelligence?
So I think these things are being applied to robotics. I think, at its core, robotics is embodied AI. So we have artificial intelligence, which is a field that has existed since the 50s, is when sort of some of the original meetings were happening to define AI. And as that has progressed, the nature of AI has changed. And so an example is in the beginning, we were thinking about ways for computers to be able to hold massive amounts of information, to be knowledge bases, to be able to recall facts, maybe to do mathematical proofs or do simple analogies, trying to replicate human intelligence sort of from the ground up. That moved into some interesting work as we started to try to extend that into the real world of the nature of visual perception. Computer vision is very hard. What our brains do all the time to make sense of the visual world is really mind-boggling, and trying to replicate that on a computer is difficult. And computer vision has tried to make sense of that visual world. There have been similar patterns for audio processing, language processing, and these forces were sort of working in different directions, sometimes combining. And robotics was one of the places these all kind of come together. Not the only place, but one of the places where all this comes together. It's really hard to move around in the real world if you can't see it. It's really hard to interact with a person if you can't hear what they're saying, or if you don't even know where you are and where you're going. And so robotics is sort of embodying that AI in the real world. As that has proceeded, AI development, in some ways, was driven by what you could make a profit on, what was made financial sense. And
Makes
so
sense.
in the 80s, you saw AI sort of being expert systems, helping people make decisions based on large amounts of data, or helping do tasks that would be really intractable for a human to do. So laying out the components on a circuit board as you start to make things much more small and much more components, the layout would be intractable for a human to do, easier for a computer to do. So you saw more and more tasks become tractable because a computer could do them. Through the 90s and the sort of early 2000s, you saw advancements that made computer vision, recognizing complex things in the real world, easier and easier. So things like deep learning pipelines for vision made some vision problems tractable. What's been happening in the last 2, 3, 4 years with generative AI is taking large amounts of language data and using those models to then try to solve problems that encompass language, or in some cases, combine language and images or video. And you're seeing this be expanded out to things that are much easier for the average user to just try to come up with a use for and develop their own uses for. And so that pipeline is now meaning that we are using AI for different things than we ever were before. Mm-hmm. It is coming to more people than ever did before, and understandable by more people than we're ever using it before. That has both benefits and costs and risks. And one of the things that we always want to talk about in this is how does it affect people who have jobs that might be doable in all or in part by AI? And so these are questions that we're always asking.
What I want to ask now is, if you're willing to explain a bit, what are you currently pursuing here in the College of Engineering? What sort of work are you currently engaged in?
I have work that I'm doing on the teaching side that is about how to bring robotics instruction to as wide a range of people as possible. This is both for promotion of the robotics minor for undergrads and a robotics master's that is also new this semester. One of the key challenges in robotics is it's a combination of many different disciplines. You can't just be a programmer. You can't just be an electrical engineer. You can't just be a mechanical engineer. You have to combine elements of all of these disciplines in order to make any robot be able to do anything. And so we are asking people who might have been trained primarily in one discipline to understand the way that other disciplines do things. And so how do we bring mechanical engineers, electrical engineers, and computer scientists together in a way that's productive and that the students are able to learn quickly, well, and be able to apply those skills both to the job market and to research. So that is a project I've got on the teaching side. It's a lot of fun. It involves talking to tons of people and making classes more accessible to people from outside of a major, which is always good. And also involves trying to think about what you would use these degrees for and how to make a real-world experience or a field experience or an industry-like experience come to the classroom. And so on the teaching side, that's a ton of fun. On the research side, my lab is primarily focused on what's called socially assistive robotics, or robots that help people through social rather than physical interactions. One of my biggest projects right now is studying how robots can be used for screening and intervention for kids that are in speech-language pathology as an assistant for speech-language pathologists. There is a dramatic shortage of speech-language pathologists in the U.S. and worldwide, outstripping even if we graduated everyone that was in an SLP training pipeline right now today, we still wouldn't have enough. We still would be at 50%.
Really?
And so, yeah, it's a big problem. And for children with speech disorders, language disorders, differences in language, there are benefits to screening children early who might have problems and providing intervention early. And the lack of SLPs means that we have a real need for increased screening. And this, whenever we say we don't have enough workers in an area, that's fantastic. That's music for roboticists, because it means that we can develop an AI-enabled solution without necessarily displacing someone's job. We can make someone work more efficient at their job. And so one of the things I'm working on in my lab is, what should that robot look like? What do speech-language pathologists want a robot to do, and what do they want it not to do? And how they can integrate that into their practice without needing them to be completely retrained in how they should do their practice. So one of the things that we're doing to enable that, we've been talking to a number of speech language pathologists, showing them videos of robots that we've got, videos of like concept art of robots that we could have, having them do activities where they start to plan, if we had this, what should it look like? What should it do? And now we are developing new robot platforms that can do what the speech language pathologists are asking for, and developing robot-assisted interventions that utilize these robot platforms along with speech language pathologists, so that this is a tool that they would actually use. That testing should happen over the course of, that development and testing is going to happen over the course of the next few years, and should be really exciting.
Wow, that is actually really interesting. So the actual AI platform, I think actually Dr. Emily Hand may have brought up something similar to or in adjacent to a project like this.
She's not working on this project, but she's got related things that she's doing for probably the computational linguistics group.
Yeah, exactly. But the robotic interface for this, what does that sort of look like as far as shape-wise? Like,
Yeah.
what sort of design does that tend to take on?
So we're not looking for something that's going to look exactly like a person.
Obviously.
What a lot of speech language intervention and screening activities look like, there's a tabletop, and there's a child sitting across the table from an SLP, and they are working with some objects, some paper, some interactive elements in between them. So what we want is something small that can go on that tabletop. So we're seeing that a lot of both the practice that needs to happen, bouncing off of another person, some kind of face, but we need it to be very expressive. So rather than having a face that is mechanical components that might not be able to move fast enough to keep up with human speech, we want something where we can have a face on a screen that can be customizable. Yeah, a research project we did recently studied how kids responded to a robot where they had drawn the face and we animated it, versus a sort of default robot face that was sort of, a drawn face, but it was not one that they did. And there was an actual benefit to personalizing the robot for the kids to have that step where they could draw the face and see the robot have the face that they made on a screen.
That is actually really fascinating. Yeah. Whoa, okay.
Yeah. So very cool stuff. And what we want to do next is make a more robust pipeline for animating that face, and then designing different activities with SLPs that will utilize that in a therapeutic context. So we're not asking for a robot that's going to be able to pick things up or move things around. This is a robot that can maybe imitate a child's speech. So they can hear what they said played back to them. Maybe even show facial interaction related to that, so it's realistic. Maybe react to what a child is saying, maybe be able to be a conversational partner. And a way for an SLP to expand an interaction to not just interacting SLP to child, but involving another interaction agent in the scene. And this whole time, all we are doing is trying to identify what can work with an SLP, not instead of an SLP. And that's the critical design consideration that we're doing throughout this.
It's the push to enhance humanity, to enhance the work we're already doing, not replace it.
Yeah, the fighting term I like to use is robots can be a force multiplier for care.
That's perfect. I haven't heard it put that way, but that is a perfect way of describing the attitude I think a lot of people should be taking with robotics.
Yeah, and one of the things that I think is a legitimate anxiety, and I think there are a lot of people that are on the other side of this, is people are legitimately concerned that their job could be replaced by a computer or by a robot. I think factory automation has displaced a lot of manufacturing jobs, and don't have the concept of what a bank teller really is anymore, because ATMs almost completely eliminated that job category.
That's true.
And so that is a valid concern. But one of the things that we want to do as part of our development is not try to replace a person, but try to utilize a person's training, make them as effective as possible in as short a time as possible, and to make their job as pleasant as possible without replacing what makes an SLP, which is significant training, focused practice, and real intelligence about how to help children. And a robot can just be an aid for that.
Well, thank you so much for coming on the podcast today, Dave. And thank you all out there who are listening. We greatly appreciate you stopping by. If you'd like to know more on how you can get involved in this sort of research and more here at the University of Nevada, Reno, you can always visit our website. Links will be in the description. And if you liked this discussion and would like to hear other interesting engineering-related topics, please like, comment, and subscribe. It's the easiest way of keeping up with the series and letting us know that we're doing a good job. Until then, this has been Engineered to Ask.